Good afternoon, Tigers. Today we're going to be working with scientific notation, and we're going to be doing something with the scientific notation. We're going to be putting numbers in order. That is our I can statement. I can place numbers written in scientific notation in order. We're going to start with comparing two numbers. The Atlantic Ocean has an area of 3.18 times 10 to the 7th square miles. The Pacific Ocean has an area of 6.4 times 10 to the 7th square miles. Which ocean has the greatest area? When comparing numbers that are already in scientific notation, really all you have to do is to look at the exponent. So I can see in my first number I have 10 to the 7th, and in my second number I have 10 to the 7th. Because the numbers are written in scientific notation, that means that because the exponents are the same, all I really have to do is look at the first number. The first number is 3.18 in the first value and 6.4 in the second. Therefore, 3.18 times 10 to the 7th is less than 6.4 times 10 to the 7th. That's what it means here. It's just comparing the first number because, once again, the exponents are exactly the same. Think about it. If the exponent is 7, that means to move the decimal 7 places to the right. So when we're comparing numbers with just one number and then a decimal, then it should make sense that, of course, the number that is smaller will be the smaller of the two. So the Pacific Ocean has the greatest area. On our Check Your Progress problem, we're going to do another example. I see 4.13 times 10 to the negative second, and I'm comparing that to 5.0 times 10 to the negative third power. Now, both of these numbers are already in scientific notation, so all I really have to do is look at the exponent. Now, this can be a little tricky when we're talking about negative exponents. If I was putting this on a number line, then I would have a -1, a -2, and -3. In other words, -3 is less than -2. So if I was comparing, then I would say this one has to be larger than the second example. If we're not quite sure, then we can always check our work. If I was changing 4.13 back into standard form, multiplying by 10 to the negative second tells me to move the decimal back 2 places to the left. That's going to give me 0.0413. Over here, I would have 5 and then move the decimal 3 places to the left. 1, 2, 3. That gives me 0.005. So I think that it's fair to say this is a 0, this is a 0, that's tenths. 4 is going to, of course, be larger than 0. Therefore, our conclusion is correct. Now we're going to do some examples together. Replace each circle with less, greater, or equal to make a true sentence. The first thing I want to do is look to see are both values in scientific notation. I would say yes, they are. I've got 1.8. That means one number or one decimal after the decimal is one digit after the first number or one place after the first number. So that is in scientific notation. In addition, 1.8, that is in scientific notation. So all I really have to do is compare my values of 10 and the exponents. We know that 3 is larger than -1, therefore that one is greater. You can't just compare, you have to make sure that they are in scientific notation first. Changing 1.8 times 10 to the third would mean moving the decimal 3 places to the right, so that's going to give me 1800. 1.9 times 10 to the negative first is going to move it back. So clearly 1800 is going to be a lot less than 0.19. Moving on to our next example. One value is in scientific notation, but the other is not. So I'm going to make both of them in scientific notation. 5.2 times 10 to the second. If I wrote 5,000 in scientific notation, I would put the decimal after the first digit. So that would be 5 times. The original decimal was here. That means 1, 2, 3. So times 10 to the third. That must mean that our first value is less than our second. I would like you to pause the video now, and when you are finished doing the next two examples, then you can start the video and check your work. 37, what we are calling 37, is not, both values are not in scientific notation, only the second value. So, so I'm going to turn both into scientific notation. 0.00701, I'm going to put the decimal to make it in scientific notation. That would mean that it's written as 7.01. I would have to count back 1, 2, 3, so that's 7.01 times 10 to the negative third power, and I'm comparing it to 7.1 times 10 to the negative third. So, I like that. The exponent is exactly the same. So all I really have to do is compare 7.01 and 7.1. This one is like $7.01. This is like $7.10. So I know this must be less than. Moving on to our last example, I noticed that the first value is in scientific notation, the second one is not. So I'm going to change it into scientific notation. That would be 6.49 times 10 to the second. Now, we have to think about this just a little bit, because in our original problem, it's not written in scientific notation exactly because this number isn't in between 1 and 9.9 or between 1 and 10, greater than 1, less than 10. However, I'm trying to multiply by an exponent. So let's think about that for a second. If it's 649 times 10 to the second, then that means that I would move the decimal exactly 2 places to the right. We know that. So when I put this in scientific notation, I now, from this position, I had to move the decimal 2 places. But now I've moved it back an additional 2, so it's between the 6 and the 4. So now that it's between the 6 and the 4, I no longer have to move it 2 places. I'm going to have to move it exactly 4 places to get it where it was before. So from this position to this position, that would be 1, 2, 3, 4. So as far as comparison is concerned, we can see that they are exactly the same. So our symbol then is going to be an equal sign. Another way to think of that is we already know that 649 times 10 to the negative, 10 to the second is 64,900. So we can see if this, in fact, is the same value. So 6.49 times 10 to the fourth power means 1, 2, 3, 4. And as you can see, it does equal the same amount. Now, we have been just comparing 2 numbers, but really our overall ICANN is to compare a list of numbers. And so I am going to change each of the values into scientific notation in order to put them into least to greatest. You can put them in order from least to greatest. So the first thing we're going to do is write each value in scientific notation. As you can see, the first one is not in scientific notation. 0.052 times 10 to the 7th. If I were to move this into scientific notation, instead of moving from this place and going 7 positions, I'm going to rewrite it just so I have a little room. 1, 2, 3, 4, 5, 6, 7. Then now I only have to move it, when I make it in scientific notation, between the 5 and the 2. Now instead of moving it 7 places, you can see I only had to move it 5 positions to get it to the second place. So in other words, when it's here, now I only have to move it 1, 2, 3, 4, 5. You can see that the second number is already in scientific notation, so I'm just going to rewrite that. Because once our numbers are in scientific notation, then we can compare them. On this example, we've got 53.2 times 10. Well, that just means to move the decimal 1 place to the right. So we're talking about 532. If I put this in scientific notation, I'm not going from this position. I'm now going from this position. So now 53.2 times 10 became 5.32 times 10 to the second power. So now I would have to move it 1, 2 times to make the same value. And then the last one, the 534, just going to be 5.34 times 10 to the second power. Put the decimal here, and then the exponent is 2 because I have to move it 2 places. Once I have the numbers listed in scientific notation, then it becomes very easy to order them. The smallest number is going to be the number with the smallest exponent. So I can see that I have 2. I have to compare 5 and 32 hundredths with 5 and 34 hundredths. Well, this is like $5.32. This is like $5.34. So we can order those fairly easily. Then we have a 5 and a 5. Same thing again. Now I have $5.20 or $5.12. 512 is less, therefore that's going to be my 3. This is going to be my 4. Now we're not quite done because let's look at step 3, which says write the original numbers in order. So I use scientific notation to order them, but now I have to go back to the original value to put them in order from least to greatest. So I have 53.2 times 10. That was my number 1. And then what do I have? 534. Mark it off. And then number 3 was 5 and 1200. That one was already in scientific notation. And then the last one, which is 0.052 times 10 to the 7th power. So you want to put them in scientific notation, and then you can order. We're going to do a couple more examples together. First thing you want to do is write it in scientific notation. So to put the first one in scientific notation, if I was putting it in scientific notation, or if I was just changing it using the 5th power, then I would move it, rewrite to have some space here. 1, 2, 3, 4, 5. But now, if I move it to scientific notation, I have to move it less spaces because look, it's already between the 6 and the 3. So that would be then 1, 2, 3, got less. So I've got 6.3 times 10 to the 2nd power. So basically it's 5 minus 3 once we put that into scientific notation. The second one, already in scientific notation, we like that part. I'm just going to rewrite it. And then the third example, we put it in scientific notation. We would put the decimal between the 6 and the 1. Minus 10 to the 1, 2, 3. The last one is not in scientific notation. We have to think about what would we do here. Well, here's the decimal. This tells me to move the decimal 3 places. 1, 2, 3. To put it in scientific notation, I'm going to have to back up one more spot. So instead of 10 to the 3rd, that's going to make it 6.31 times 10 to the 4th. Once I have the numbers all written in scientific notation, then we want to order using exponents. And I can see that I have a 2 here. I don't see any other 2s, so that must be my 1. And then I've got 3. That's the number here. That's going to be my number 2. And then the last one isn't so obvious because I have a 10 to the 4th and 10 to the 4th. So now I have to think about what is that. That's like $6.03. That's like $6.31. That will be my number 3. This will be my number 4. Once you do that, then you have to go back to your original value. So if I want to finalize my answer, here's the first one. If it makes it easier, you can mark those off. The original was, what, 6,103. I'm going to make these semicolons just because I got a comma there. I'm going to mark that one off. 3 was our original scientific notation problem. And then the last one is 63.1. 63.1 times 10 to the 3rd. All right. One more example. I know it takes some brain power, but I also know that you can do it. Now, the only thing that's different about this problem is that you have negative exponents. So, as far as negative exponents are concerned, we still want to put it in scientific notation and then just think number line. So, we're still putting in least to greatest, so we're trying to find the smallest number to the greatest number. On our first example, you know I have to rewrite it, so I have a little space. I'm multiplying by 10 to the negative 5th power. So that means to go back 1, thought process, when I'm here, and I have to move 5 places to get it to its answer, because this number is a value. Even though it's not scientific notation, it's still a value. But if I put it in scientific notation, then I'm going to put the decimal now here between the 6 and the 3. So no longer do I only have to move 5 places, but I'm going to have to move a 6, a 7, and an 8. So in scientific notation, this number is 6.3 times 10 to the negative 8th power. This one is already in scientific notation. This one is not. I have to move it. Excuse me, a 6 and a 1. So we have 6.3 times 10 to the negative. We have to move it 1 place. So that would be a negative 1. We know that negative exponents go along with numbers that are less than 1 whole. And then came this one, 63.1 times 10 to the negative 3rd. So that would be move it back 1, 2, 3 places. So that's 0.0631. If I put it in scientific notation, then the decimal goes between the 6 and the 3. Therefore, I only have to move the decimal back 2 places. So that's 6.31 times 10 to the negative 2nd, where before I had to move it back 1, 2, 3. Now I only have to move it 2 places once it's in scientific notation. I would like you to stop the video, and I want you to order these. So now that we've had them on scientific notation, see if you can decide what is the least number and what is the greatest number. Once you're finished, then go ahead and start the video. As far as the exponent rules are concerned, I go back to our number line. Our smallest number is going to be, we're looking at the exponent, is going to be negative 8. So I know right away that is going to be the first one. And then next would be our negative 4. That would be number 2. And then we have to decide between negative 1 and negative 2. Well, we know that negative 1 is closer to 0, so that's going to be our greatest. This one would be in between. Then we want to make sure that we write the original. So I'm going to go back and do that. You can write that on your paper as I'm doing that here. So we wrote them in scientific notation, and now notice that I am writing the original. So I did my 1, number 2. I just finished up number 3, and then last but not least, 6.03, right? Not least, it's the greatest. Ha ha. All right, so that is going to do it